Hello, my name is Narasimha Arun. This is the video demonstration of socket programming project called Checkpoint Application. This demo is extension of project milestone 1, and our group is group 15. My teammate is Sai Rahul Kandala. So for this demo, I have already opened 4 terminals and started my bank process and 3 customer processes. So I have used general 3 and general 4. So here you can see general 3 and general 4 of ASU generals, where I'm using general 3 for bank and general 4 for 3 customers. So here you can see the IP address of general 3 is 10.120.70.105, and the IP address of general 4 is 10.120.70.146. So as suggested by professor, I have actually started the bank process, and it is running at 8600 port, and I have created customer process C1, and it is running at port 8600 and 8601. So here I have opened a bank account with $100 in the bank account. So the bank received the response is success. So the customer C1 has a bank account and has a bank balance of $100. So in here also we have customer C2. So it is running at port 8602 8603, and here we opened the bank account with $150. So customer C2 has $150 in the bank account, and similarly for the customer C3, it's running at 8604 and 8605 ports, and we are opening a bank account with $200 in the bank account. So now that we have created 3 customers and all the processes are running, so we can go ahead and create a new cohort. So I'm using customer C2 to create the new cohort, customer C2 with the 3 customers in the cohort. So you can see that we have received the customer tuple to the customer C2, and C2 sends it to C1 and C3. So we have cohort details sent to C1 and C3. So at C3 we can see that we have received a customer cohort, and at C1 as well we can see that there is a customer cohort received at their end. So right now we'll perform some deposit and withdrawal operations at all the customer ends, just to make sure that they are working, and after that we'll perform a transfer operation between the customers. So at customer C1, let me deposit some $50. So initially it has $100 in the bank account, as we can see. Now the updated bank balance is $150. So the deposit is working. Now withdrawal, I'll be withdrawing $30. So it is 150 minus 30, it's $120 in the bank account. So similarly we'll do at C2 and C1, C2 and C3. Deposit same, do $40 here. So you can see that it has 150, and we have the updated balance of 190. And then we'll perform withdrawal operation of $20. So now you can see that updated bank balance is $70. Similarly, we'll perform deposit of $100 here. Deposit 100. So you can see in previously it has 200. The updated bank balance is 300, and withdrawal of $50. So you can see that from 300 it has become $250. So now what we'll do is we'll transfer some money to from C2 to C1, and then C3 to C1, and at C1 we'll be enforcing a checkpoint. So we can perform transfer and $20 to customer C. So you can see that previously the bank balance is $170 and we have transferred $20 to C1. So in this command the user don't know the label, but here we'll be having the label sent in the command. So you can see that the first label sent here for C1 is updated to 1, previously to 0, and the bank balance has decremented from 170 to it became 150. And here as we can see that previously it has $120 in the bank account, and it received transfer of $20 from C2, so the bank balance is updated to $140. And the last label received, so from which it received is C2, so we are incrementing the C2 count, and the C2 is added to the checkpoint cohort of C1 because it received the transfer, so we are updating the state variables. And similarly we'll be performing transfer of $50 to C1. So you can see that previously it has $140, and when we transfer $50 it has become $190. And the last label received here is C3, but received from C3, so we are incrementing the count here, and the C3 is added to the checkpoint cohort of C1. So C2 and C3 are right now present in the checkpoint cohort, and here you can see the balance has decremented from $250 to $200, and the first label sent here is incremented of C1. So here around checkpoint will force a checkpoint. So when we force a checkpoint initially in the checkpoint cohort of C1 and of C1, so it sends a tentative checkpoint to C2 and C3. Once they take a tentative checkpoint, they reply with yes, and once they reply with yes, then C1 will be sending take permanent checkpoint. So both the customers will be taking permanent checkpoint. That will be our global state. So when C1 issues checkpoint, so at the end of C1 we can see that it's saving a tentative checkpoint, all the state variables. Then the checkpoint cohort you have C2 and C3, so we are sending take tentative checkpoint from C1 to C2. So if you see that from at C2 you received take tentative checkpoint from C1, so we have received one tentative checkpoint, and it is saving to tentative checkpoint. And once it is saving to C2 is saving to tentative checkpoint, we'll be sending a reply command yes, so it's saying it's ready to take the checkpoint. And once it takes the checkpoint, the customer the C1 sends one take tentative checkpoint to C3. So here as well we can see that we have received take tentative checkpoint from C1. So the customer C3 has taken a tentative checkpoint, and once it is taken a tentative checkpoint, it sends a reply yes. So on receiving both yes from C2 and C3, we'll be making a permanent checkpoint. So C1 will be making a permanent checkpoint, so this is the permanent checkpoint. And there is a design constraint, design decision which our team has implemented, that once it is taken a permanent checkpoint, we'll again be setting all the state variables to default. So you can see that last label received and first label sent are set to 0, low 0, and here we are setting to 999, so which is top, as described in the design document, as described in the project description. Now once it takes a permanent checkpoint, it sends make tentative checkpoint permanent to C2 and C3. So here we receive make a permanent checkpoint. So here it is making a permanent checkpoint. You can see that previously there are state variables updated, but again we are setting those state variables to default suggested by professor in the video description. And similarly at C3 as well, we have we got that make permanent checkpoint so from C1. So now it is making a permanent checkpoint and all the state variables are set to default. So here you can see that the checkpoint cohort is deleted because we after once it is taking a permanent checkpoint, again this checkpoint cohort will be updated. So yes, we'll be performing the same set of operations and we'll be implementing the checkpoint at C2. Now C2 will send a transfer message from C1 to C2 and C3 to C2. Then at C2 we'll be enforcing a checkpoint and we'll just see that. So we'll be transferring $20 to C2. Then you can see that the C1 hit C1 we have decremented, so from 190 it became to 170 and the first label sent has become 1 at C1 and the last label received here at C2 for C1 it's become 1 and from $150 you can see that from $150 it has become to $170 and similarly we'll be sending a transfer of $30 to C2. So you can see that it has become $170 and the first label sent at it has become from 200 to 170 as we are transferring $30 and the first label sent has become 1 here and the last label received for C3 it has become 1, so we have implemented that and the checkpoint cohort you can see both C1 and C3 are added here. So now we'll be sending a checkpoint. So remember this, like the checkpoint at C2 here we have $200, at C1 we have $170 and C3 we have $170. So here we'll be sending a checkpoint. So once it is sending a checkpoint, so you can see that it sends take tentative checkpoint to C1. So at C1 it received take a tentative checkpoint and it has taken a tentative checkpoint and C1 has replied yes to C2 and similarly C2 has sent take tentative checkpoint to C3. So here you can see that at C3 we have received a tentative checkpoint. So once it is received tentative checkpoint it sent a reply yes to C2. After receiving both yes from we have received yes and yes here, so once it is receiving yes and it makes a permanent checkpoint. So at C2 here it took a permanent checkpoint and you can see that all the state variables are again set to default. So and it made it a permanent checkpoint and it says to C1 and C3 to make the tentative checkpoint permanent. So you can see that here both of them are making their tentative checkpoint to permanent and all the state variables have been set to default and even here as well. So yeah, so you can see that 170 and here you can all the state variables are set to default and here we have deleted the checkpoint cohort as well. So this is a consistent global state and right now we'll do some deposits and transfers here, so and then followed by a loss transfer. So at C2 I'll be depositing some $50. So the updated bank balance is 250 from 200. Then I'll be withdrawing $10. So it has become $240 and now I'll be sending a lost transfer to C1. Of $40 to customer C1. So when I send a loss transfer, you see that from $240 it has become to $200, and all the state variable here has been updated, the first label sent, and here it says that transfer is lost. We can see that from the previous permanent checkpoint there is no new message arrived at C1, so this indicates that the transfer is lost. So now we'll be sending a legitimate transfer of $100 to customer C1. So when we send this thing, it should detect there is a inconsistency. So here you can see that the balance has been updated and the first label has been incremented, and now you can see that at customer C1 it has increased from $170 to $270. So the checkpoint cohort has been updated, but the OK to take checkpoint is become no. So previously it is yes, and now it has become no. So this indicates that it has detected a inconsistency in the global state, and it won't be receiving any further what do we say, any further I mean the transfers might be happening, but it won't be taking any checkpoint. So now we'll be forcing a rollback. So the rollback will be forced to go back to a permanent checkpoint. The previously took permanent checkpoint. So now I'm issuing the rollback from C1. So you can see that the rollback has been updated. So it has rolled back to the consistent global state. You can see that so when we have sent a rollback, so it initiates the rollback algorithm, and we had the cohort tuple. So now we are sending a prepare to roll back to C3 and prepare to roll back to C2. Once it is preparing to roll back, the customer C2 will be sending yes to C1, and customer C3 will be sending yes to C1. So that means they are ready to roll back. Once it is ready to roll back, now as per the algorithm, it should be rolling back to the previously taken permanent checkpoint. So you can see that here we have made permanent checkpoint at $170. So it has been rolled back to $170, and previous at C2 here we can see that we have made a permanent checkpoint at $200. So you can see that $200. After that we have performed some deposit and withdrawal, then there is a transfer lost, and there is a again legitimate transfer. So it has been again rolled back to $200. So we have, as we told, that after taking a permanent checkpoint, all the variables state variables are set to default values. So here as well you can see that the data has been rolled back so to $170. As a rollback as we see, the rollback algorithm will be sending the rollback to all the customers in the cohort tuple. So now you can see the rollback. So it went to the consistent global state. Now we can successfully delete the cohort. So we'll be deleting through C1. So deleting the cohort through C1, and you can see that at all the end we have deleted the cohort tuple successfully, and here as well we have deleted the cohort tuple successfully. So now these customers are free to exit. So you can exit C1 from the application, then C2 will be exiting from the application, then C3 will be exiting the application, and I'm terminating the bank process. So control, you can terminate the bank process, and that's the demo. Thank you for watching.